Hey everyone, in this video I'm going to work through an example problem for hypothesis testing for two population proportions. So random samples of 100 US companies in 2020 and 127 companies in 2021 were taken to identify whether high deductible health insurance plans were offered to its employees. It was found in the sample for 2020 that 19 of the companies offered such plans, and this increased to 31 in 2021. So, can we conclude with a 0.10 level of significance that US companies are offering high deductible health insurance plans? Let's conduct the hypothesis test to find out. Here, we can see the hypothesis statements are constructed in the format P subscript A minus P subscript B. In the problem, it indicates that A will be for the year 2020 and B will be for the year 2021. The first task is to determine if this is a one-tailed test, either an upper or lower, or two-tailed test. Then we need to complete the hypothesis statements. We know that hypothesis statements for two population proportions are always stated in terms of zero, but what are the signs we need to use here for the null and alternative hypotheses? Based on what we were told in the story, we know that we're interested in proving whether the population proportion for the companies sampled in 2021 is higher than the companies sampled in 2020. So we can start with the statement P sub 2021 is greater than P sub 2020. We need to now phrase that in the terms of zero, so we could rewrite it as P sub 2021 minus P sub 2020 is greater than zero. However, we can see from the given hypothesis statements, 2020 or A was referenced first. So we could then rewrite it as P sub 2020 minus P sub 2021 is less than zero. Now all we must do is replace the 2020 and 2021 with A and B respectively, and that is your alternative hypothesis. Let's go ahead and plug in less than zero there. We know that the null hypothesis will always have the equality sign in it, and it's going to be the opposite of the alternative hypothesis. So we can go ahead and plug in greater than or equal to zero for the null hypothesis. Finally, since the sign is pointing to the left for the alternative hypothesis, we know that this is a one-tailed lower test. Now we're going to calculate the z-test statistic. First, I will walk through the calculations and then I'll switch over to Excel to show you how you can use Excel as your calculator. So in step 1A is to calculate the sample proportions for the samples conducted for 2020 and 2021. So in 2020, 19 out of the 100 companies said they offered high deductible health insurance plans. So you divide 19 by 100 and you get 0.19. In 2021, it was 31 out of the 127 companies. So we divide 31 by 127 and we get 0.24. So in step 1B, we're now going to calculate the pooled estimator for the overall proportion. However, instead of using this formula that calculates X for each sample in the numerator, we can use this simplified formula for the pooled estimator. We're going to go ahead and plug in 19 and 31 in the numerator for X sub 1 and X sub 2, and 100 and 127 in the denominator for N sub 1 and N sub 2. Do that addition, and we get 50 and 227. Now we're going to go ahead and do that division, and we get 0.2203. Okay. Now we have everything we need to calculate the z-test statistic. We're going to plug in the sample proportions from step 1A for P bar 1 and P bar 2. We always use that difference in the population proportions is 0. Now we can plug in 0.2203 for P bar in both spots, and 100 for N sub 1 and 127 for N sub 2 in the denominator here. Now in the numerator, we subtract 0.19 from 0.24 and we get a negative 0.05. The denominator here is where it gets tricky and you want to watch out for your order of operations. But if you do this calculation, you get 0.0554. Finally, take negative 0.05 and divide it by 0.0554 and you get a negative 0.98. All right, let's do these calculations in Excel now. All right, here is the Chapter 10 Excel resources. First, let's calculate the sample proportion for 2020, which is P bar sub 1. Plug in 19 and 100. Then we'll do equals 19 divided by 100, will give us 0.19. Then for the sample proportion for 2021, which is P bar sub 2, we had the 31 and then the 127. we'll do equals 31 divided by 127, and we get 0.24. Here's our formula for the pooled estimator, but we're going to use the simplified version because in this story we were told the x1 and x2. Let's go ahead and just reference these cells that we just typed in. Now we could just add the numerator as well as the denominator. Finally, we could do the division, 50 divided by 227. That gives us a pooled estimator of 0.2203, which we know is correct. Now let's calculate the z-test statistic. Let's go ahead and plug in our references for p bar sub 1 is 0.19 and 0.24. We know that the hypothesized difference in the population proportions is 0, so we'll plug in 0 there. Let's go ahead and reference our cell for our pooled estimator. And let's reference our n sub 1 and n sub 2. In the numerator, we'll take 0.19 and subtract 0.24. We don't need to subtract 0 because that's not going to have an impact. And we get negative 0.05. Here's where it gets tricky, but we're going to use Excel to do our calculator, but we're going to work on it from left to right. First, let's take 0.2203 times 1 minus 0.2203. Then we're going to multiply by, open parentheses, 1 divided by 100 plus 1 divided by 127. Click enter. We know this is not the correct answer because we still need to do the square root. I like to break up the calculations in parts to avoid errors in your formula in Excel. So we got a good output now, and we could just apply the square root function to the whole thing. And we get 0.0554, and now all we got to do is do the division. Equals negative 0.05 divided by 0.0554, and we get a z-test statistic of negative 0.98, which we also know is correct. All right, now we're ready to reach a decision and draw a conclusion. We will conduct the hypothesis test using the critical value and p-value approaches, but you may only need to do one of these either way depending on your problem. In step 2a, we need to calculate the z critical value. In Excel, we'll type in norm.s.inv and 0.10 for alpha for a lower tailed test, and we get a negative 1.282. Here's a visualization of the standard normal distribution, and here is that cutoff critical value. We can see that the z-test statistics of negative 0.98 is here, which is in our do not reject region since it's greater than the critical value. Let's now calculate the p-value in step 2b. In Excel, we'll type in norm.s.dist and negative 0.98 for z and true for cumulative, and we get 0.164. This is consistent with the critical value approach since this is not less than the significance level of 0.10. So now we're ready to draw our conclusion on the two samples. We do not reject the null hypothesis. There is insufficient evidence to conclude that there is higher proportions of US companies offering high deductible health insurance plans to their workers in 2021 than in 2020. Well, that wraps up this tutorial on conducting a hypothesis test on two population proportions.